Okay, so that's the first question. It was a quadratic equation, and we could easily solve this by factorizing and then getting the answers from there. For this next question, if you look carefully, you can see it has a lot of resemblance to the first question. It's also a quadratic equation, but this one we can't factorize. Okay, and it's hinted to the fact that this one can't be factorized by them saying that we need to correct our answers to the 2 decimal places. Okay, so that already tells me, okay, this is not going to be a rational answer. This is going to be irrational values. And for irrational values, we can't factorize. And this is why we'll be making use of, instead of factorizing, we'll be using the quadratic formula. Okay, so what's the quadratic formula? Negative b plus minus the square root of b squared minus 4ac divided by 2a. Okay, so now the important thing is not you knowing the formula, but substituting correctly into this formula. Okay, and I need you to also write down your substitution. So I'm going to replace the b with a negative 2. Sorry, not negative 2, the negative 3. The one that's in the middle. Okay, that's your negative b. Then a is the 2 that's in front. And c is the negative 3 at the end. So both b and c is negative 3 and a is 2. They come from the coefficients of this quadratic equation. Okay, I don't have a calculator with me, but I'd like one of you to give me the answers to this, please. So go ahead, punch this into your calculator. And once you have the answer, type it in the chat so that we can move on to the next question. Okay, I got an answer from Devin. Just tell me if this is the correct answer. You confirm it with the answer that you got. So I got 2.19 and negative 0.69. Let me just check if I got that correct. 2.19 and negative 6.9. Yeah. What do you guys say? Is that fine? No objections? Okay. Okay, thank you, Devin. Okay. This third question, even though it looks similar to these two, and you will kind of solve it in the same way, but there is a slight change here. This is no longer an equation. Even though it's quadratic, it's no longer an equation. It's what we call an inequality. Okay, and to solve an inequality, we're going to do something different. Just our answer won't be exact answers like it was for these equations. We got exact answers. We said here the answer was 4 and 6. And then for here, this answer was 2.19 and 0.19. But for the inequality, it's going to be a whole range of answers that can satisfy this inequality. Okay, so your answer is not just going to be x equal to, but will either be x is greater than or x is less than. Right. So let's have a look at this one. We have x squared plus 5x less than or equal to negative 4. Okay. So I said we're going to treat it very similar to the quadratic equations that we had before. So I'm going to take the negative 4 across, and then we're going to factorize. Okay, the factors of 4 to give us 5 is obviously just 4 and 1. because 2 and 2 won't give you 5, so it has to be 4 and 1. Okay, both signs will be plus inside the brackets. And this is not your answers, but this is what I call the critical points. The critical points will be where x is equal to -4 and where x is equal to -1. Those are your critical points. Okay, we are now from that going to find out our answer. We're going to write down our answer. So to do this question, I'm first going to draw a graph. So let me draw the x-axis. And then because this is a quadratic equation, I'm going to draw a quadratic function. And a quadratic function has the special name parabola. Okay, so there's your parabola. The x-intercepts will be where the equation is equal to 0. So it's the -4 and the -1. Okay, so -4 and the -1. Now you always put the smallest value on the left and the bigger value on the right. The smaller value in this case is -4 and the bigger value is the -1. Okay, now here we are asked, where is this expression less than 0? Where is this expression less than or equal to 0? So we already can see where it's equal to 0. That's at -4 and -1. But it's also less than 0 between -4 and -1. It's the whole section of the graph that is below the x-axis. Okay, that is where it is less than 0. So, in saying that, how do we now structure our answer? Okay, let me erase the drawing so that I can give you the answer. It's the whole section between -4 and -1. So I'm going to say all the x values greater than -4, but less than -1. Okay, so I'm just going to pause here and ask, is there any questions at this point? So then let's move on to 1.1.4. This is what we call a third equation. So we have 1.1.4, a third equation. Again, guys, if you're not going to remember it, please write it down. Third equation. Why is this called a third equation? Because of the square root that you see there. Okay. Third equation. Right. And if you know the different kinds of equations, you'll then know the different methods to solve them. Okay. By the way, this third goes all over the 28. So it covers the x and the 28. Okay. To solve third equations, my first step is always make sure the third is all on its own. So I say isolate the third, get it all on its own. Once it's all on its own, you then can square both sides to get rid of that third, because the opposite of a square root is a square, right? So if you square, it cancels with the square root, which means you're just left with x plus 28 on the one side. Okay. On the other side, we are going to square that out. Okay, so I'll square the first term, which is 4. I'll also square the last term. Now remember, even though that is -x, if you multiply -x with itself, so you say -x times -x, you get +x squared. Okay, but now let's not forget that there's going to be a middle term when you multiply this x with that 2, and again the 2 with the x. Because remember, that bracket is repeated. Let me just show you the foiling that happens. That's 2 minus x, then again 2 minus x. So we multiplied the 2 with the 2 and the x with the x. But what we also must remember is to multiply the 2 with the -x and the -x with the 2. Okay, so there's those other two multiplications that must also happen. Right. Now, if we do that, if we multiply the 2 with the x and again the 2 with the x, if you add up those like terms, you get minus 4x. Okay, so you can always use the shortcut method by just doing that multiplication twice and then writing your answer there. Okay, this is again what we call a quadratic equation. You always classify the equation according to the highest power. So since in this case the highest power is 2, this is what we call a quadratic equation. Okay. Again, we're going to solve this quadratic equation by forming a trinomial and then factorizing. So it will start with x squared. And then I have the negative 4x over this side. I have a positive x on that side. But remember, I'm taking that positive x over, so I'm going to minus it, right? So it's negative 4x minus x, which gives me negative 5x. And the 28 is also going to come across. So if we have a 4 on this side and you're minusing 28, what is that equal to? Negative 24. Okay. So if you have a look now, can you see that this equation is very similar to this one that we had in the beginning? It's very similar to 1.1.1. The only difference is that there's a different middle term. Okay. So we're still going to find the factors for x squared and the factors for 24, but instead of looking for the 2, we're now going to look for the 5. Okay, we now need to find the factors that adds to 5. Oh, sorry, subtracts to 5. Made a mistake there. There's a minus, so it should minus to 5. Okay, so I'm just putting my x's there. Now the factors of 24 we said was 24 and 1, 2 and 12, 3 and 8, and 4 and 6. Okay. So 3 and 8 is going to give us 5. If I say 8 minus 3, that's equal to 5. But if we want to get negative 5, I have to say 3 minus 8. So the 3 has to be positive and the 8 negative. Okay. Which then gives us the answers. What's the answers here? Negative 3 and positive 8. Okay. Negative 3 and positive 8. Okay. Once you're all done with your answers for a third equation, it's always important to check if these answers are correct. Now, I recommend that you check all your answers, okay? But certain things is much easier to check. Like, for instance, these answers here is much easier to check rather than this ones here, because here you have decimals. Okay, so don't waste your time checking everything. But if you can check if your answers is correct, then go and do that. But the most important thing, the most important equation that you need to, I guess, check if your answer is correct is for a third equation. Because for this third equation, only one of those solutions will be viable. The other one, not. So let's check which one is correct and which one doesn't work. If I substitute x with negative 3, okay, so now let's take this left-hand side and substitute x with negative 3. So that's going to be negative 3 plus 28, which is 25. So the square root of 25 is equal to 5. Okay, so we have the left-hand side, which is equal to 5. Now let's have a look at the right-hand side. The right-hand side is 2 minus x. So we have the right-hand side being 2 minus, now remember x is negative 3, so it's minus negative 3. Now, when you minus a negative number, you can basically change that double negative to a plus. So it's 2 plus 3, which is also 5. Okay, that must mean that this answer of negative 3 works because the left-hand side is equal to the right-hand side. Right, let's see if the same thing doesn't apply if I substitute 8 as my x. So let's substitute 8 for this. We get the square root of 8 plus 28. Now 8 plus 28 is 36. And the square root of 36 is 6. Okay, cool. Let's do the next one. 2 minus 8. 2 minus 8 is equal to negative 6. That's not the answer we got for the first one. 6 is not equal to negative 6, which must mean that this 8 is not valid. So I'm going to draw a line through that one to show that the 8 is not valid and the negative 3 is the only valid answer. Okay. And that's that. Any questions? You get a mark for showing which answer is invalid. Okay, so please make sure after calculating your answers, check the third equation to see which one is valid and which one is invalid. Right. So question 1.2, here we have a simultaneous equation and we need to solve x and y for this. The best way to solve simultaneous equations, and it might even be the only way in this case, is to make x or y the subject of the formula. Now again, I say, if you don't know this, write it down. So the first step is make x or y the subject of the formula. I want you to write that down if you didn't know it. Okay. That's the first step for a simultaneous equation. Okay, now I'll take the smallest equation because it just seems logical to do that. We'll take the 2y equal to 3 plus x. And what must I do? Make x the subject of the formula. It could be x or y, but obviously in this case, it's better to make x the subject of the formula because I can just take the 3 across. So x is equal to 2y minus 3. Okay, easy peasy. Now we'll be using the substitution method, which means I'll have to substitute the answer that I got for x into this next equation. So this answer, the 2y minus 3, needs to be substituted with the x, in fact, both x's in this equation. Okay, so let's rewrite that equation first. We have 2xy plus 7 equal to x squared plus 4y squared. We're going to substitute our answer into that. So this is going to go over here, and this is going to go over here. Now, I don't think most people get confused with this part. It's after the substitution, that's where the mistakes comes in. So let's do it slowly so that there are no mistakes. So you have 2 bracket, and I'm going to put in blue the substitution, 2y minus 3, close bracket, and then we have the y that's outside. Right, it's plus 7 times, okay, put in brackets, the 2y minus 3, because that's our x, 2y minus 3. And this is equal to, nope, sorry, not equal to, sorry. And this plus 4y squared. Okay, cool. Let's do the multiplication now. Okay, so this is a very confusing process because You have a 2 in the front of the bracket, and then you have a y behind the bracket. Why don't you put the 2y in front of the bracket? Both the 2 and the y. Let's put that in front of the bracket, and then we'll do our multiplication like that instead. Okay, so I'm putting the 2 and the y both in front of the bracket because I'm still multiplying, you know? So it doesn't matter in which order you multiply. I can multiply the 2 with the y first and then multiply that with the bracket because the order of multiplication doesn't matter. Okay, so 2y times 2y gives us 4y squared. 2y times negative 3 gives us negative 6y. This bracket we're going to have to square out, and then let's write our values for all of that. So the first one is 4y squared minus 6y plus 7 equal to, let's square this bracket out now. So that's going to be 4y squared. Let's not forget to square the 3 also, so that's 9. And then 2 times 3 is 6. So we have 6y, but remember we have to double that because it happens twice. So it's negative 12y plus this 4y squared at the end. Okay. The only mistakes that happens here is just multiplication. And I've seen countless times that this is where the mistakes happen, right? It's either here with the 2 and the y being split like it was, or it's here where you have to square the brackets, okay? And sometimes the mistake is as simple as forgetting, you know, forgetting perhaps the 4y squared at the end. Okay, that's very unfortunate when that happens. Okay, let's add our like terms and then solve the quadratic equation. Okay, this 4y squared on this side will cancel with the 4y squared on that side, because if I take it over, it's going to cancel. So I'll just be left with this 4y squared on here. So we have 4y squared over there. Then negative 12y plus the 6y, because I'm taking it over. So plus 6y. And then lastly, it's the 9 and 7, the constants, the 9 and the 7. So it's 9 minus 7, which is then 2. Okay, I'm going to solve this quadratic equation quick. So we'll first divide by 2. Then we're going to factorize. And then put our signs in the bracket and write down our answers. Okay. Remember, this is not the final step because the question was to solve both x and y. So let's recall what was our equation for x again. X, why is it not working now? X was equal to 2y minus 3. I hope I'm not making a mistake. It's 2y minus 3.
Excuse me, sir?
Yes?
Why is it plus 6y?
Did I make a mistake?
I don't know,
I
sir.
did. I did. It's supposed to be negative 6y. Thank you so much. Thank you so much. It must be negative 6y, which means both the signs in the bracket should then also be negative, which also means that our answers will both be positive. So y will be equal to positive a half and positive 1. Thank you so much. That was Jessie, right?
Yes, sir.
Okay, thank you. Now I'm going to be substituting these answers back into my x equation so I can find the answers for x. So y is a half and y is equal to 1. Let's substitute y with a half first. A half times 2 is 1. 1 minus 3 is negative 2. Okay, so that's the first question. The first solution. The next solution is where y is equal to 1. 2 times 1 is 2. 2 minus 3 is negative 1. Okay, and those are your answers for x and y. Let me just put the ticks here so you can see where you get your marks. Sorry, not where you see you get the marks, but just so you can see where the answers are. It's a half, it's 1. Those are the answers for y. And then it's negative 2, and it's negative 1. Those are the answers for x. Thank you for that, Jesse. You can see, guys, you can see how easy it is even for me to make a mistake. And it's a mistake that I probably wouldn't have even picked up unless I checked it with my original equations. Okay, that's the only way you'll be able to see if you actually got the correct answers. If you go and test them with that original equation that was given and see, okay, does the left-hand side equal the right-hand side? If I substitute these values for x and y. And if it doesn't, then it means you obviously made a mistake along the way. So if I was writing this exam and I checked my answers afterwards, I would be super frustrated because I'd feel that I did everything correct and here is my answers are wrong. And this happened countless times to me. It's very frustrating. I know it might even happen to you as well. I hope not, but just make sure that you're being very thorough, because mistakes like that can creep in for no reason. Let me just check the time, because I think the only question we have left to do is nature of roots. We did all the kinds of equations. Actually, I didn't do any exponent equations, but hopefully we can do that as well. Yes, okay. So there's still a bunch of time left, more than 15 minutes. The last question here. So let's read it together. The roots of an equation are x is equal to negative n plus minus the square root of n squared minus 4mp, where m, n, and p are the positive. Sorry, let me highlight that part because that's important. M, n, and p are positive real numbers. The numbers m, n, and p in the order form a geometric sequence. Ooh, this is a geometric sequence, m, n, and p. Prove that x is a non-real number. Prove that x is a non-real number. Wow, so nice. Okay. Now, let's think in terms of nature of roots. Okay, when we think in terms of nature of roots, we usually make use of delta, which is our discriminant, to determine the nature of the roots. So if delta is greater than 0, we know we have real roots. If delta is less than 0, we have the opposite, which is non-real roots. And if delta is equal to 0, we have what you call equal roots. Okay, so this is just your basic principles of nature of roots. You need to know these things before tackling any question of this sort. Okay, so here we are going to pay close attention to this middle one, which is where delta, the discriminant, is less than 0. Okay, because we want to prove that this solution for all values, let me see, for all the values of m, n, and p, there will be no solutions for this. Okay, so let's just keep in mind what they are telling us, and then let's see if we can prove this. Okay, let me first write down the geometric sequence. So GS for geometric sequence. M, N, and P. We know that geometric sequences has a constant ratio. So N over M is equal to P over N. Okay, which must mean if I, simplify this equation, and I, for instance, cross multiply, that N squared is equal to MP. N squared is equal to MP. Okay, you saw what M squared is equal to MP. Right. This is going to be very handy in answering this question. So I want you to copy this down. I'll just give you like a few seconds to copy that down. Okay, so you all understand this, right? M, N, and P is a geometric sequence, which means the ratio between the second term and the first term should be equal to the ratio between the third term and the second term. It's like that formula you used to write, where you say T2 over T1 is equal to T3 over T2. No? This is the formula you normally use for geometric patterns. Okay, so that's what I said. And then I also just cross multiplied. I said n times n is n squared. And then m times p is mp. Okay. So we want to determine the nature of roots, and we want to prove that the discriminant delta is less than 0. Because remember, if we can say this, if we can prove this, then it means that we know that there's non-real roots. Okay. Now, delta is equal to b squared. Well, in this case, it's n squared minus 4mp. Okay, you see that? No? That's your delta there inside the square root. So it's n squared minus 4mp. Okay. But if you look at our previous equation that we just got now, we said that n squared, let me write it again, n squared is equal to mp. I'm going to substitute this mp for n squared. Well, I'm going to substitute that mp with n squared, because the two are equal to each other. And then let's see what happens. So I'm manipulating my equations here. So n squared is equal to 4, and I'm substituting the mp now, watch, with n squared. Okay. Actually, I don't need brackets, so let me just write n squared, normal. N squared. Okay, so we have n squared minus 4n squared, which is equal to negative 3n squared. Okay, you guys know how to add like terms. Now, see here. N, what did they tell us here? N is a positive real number. It's a positive real number. Okay, now if you square a positive real number, you still get another, it will be a bigger, but it will be a bigger positive real number. Okay, in fact, it doesn't have to be bigger. Like sometimes you square a half, then it equals a quarter. And a half is a positive real number, but there where you square it gets smaller. So I shouldn't say it's going to get bigger, but in any case, if you square n, whatever n is, it's going to remain positive and it's still going to be a real number. Okay, so we understand that part. But once you multiply that positive number with -3, then it changes to a negative real number. Okay, which means that delta will therefore be less than 0 for all real values of n, and therefore this, I guess, equation will always have non-real numbers. Okay, so therefore the equation or this equation for x will always have non-real values because delta is always going to be less than 0. Okay, any questions? Let me just pause the recording. Any questions? I'd like you to now attempt 3 questions. Let me just zoom in on the questions. Here we go. Okay, so the first question is 1.1.3. The next question, 1.1.4. And the last question, 1.3. Okay, those are the questions I want you to tackle now. I'll give you about 10 minutes to do it, and then we'll have a look at the answers afterwards. Okay, go for it. Okay. 1.3 is easy because we had a look at a question like that already. Where it's I think I forgot it again. Let me just check if this is the correct one. Yeah, 4x squared minus 1 is less than 0. Okay. So because it's quadratic, you would factorize it. Remember, quadratic equations always has 2 answers. Okay. So here you would factorize. You'd find the factors of 4x squared, the factors of 1, plus or minus because it's difference of squares. So your answer for x is either positive 1/2 or negative 1/2. Those are your critical points, pardon me, not your final solution, just your critical points. Okay, now this is how we do it. We draw the horizontal line, which represents 0, and then we draw a quadratic function. And the negative 1/2 will be on the left hand side and the positive 1/2 will be on the right hand side. Okay, so now we are trying to find out where it is less than 0. So it's the entire section below the line, below 0. And therefore your answers is all the x values greater than negative 1/2, but less than 1/2. Okay, can I just see by a show of hands how many of you got this question correct? So just show the thumbs up so I can see how many got this one correct. So let's move on to the next question. The next one is a third equation, but it looks a bit funny. Let me just see if I remember it. Square root 32 plus x. Okay, square root 32 minus x. So we have the square root of the square root of 32 plus x times the square root of the square root of 32 minus x, and this is equal to x. So they just put nice brackets around it, like this, but those brackets means that you'll be multiplying the 2 square roots. Okay, so can I hear, Cole, I'll first hear by you. How did you attempt this?
So I first like simplified the square root of 32.
How did you do that? What do you,
Um,
so you got 4 root 2, is that correct?
yes,
Okay.
I forgot what the word for it is.
Okay.
then I took away. Oh, now that I'm thinking about it again, can't you multiply both of them together and then just take away the square root on both? Or yeah, just
You can multiply them together, but the square root doesn't disappear. Can I just explain why? If you, for instance, have square root 3 times square root 3, and you choose to multiply these two, that gives you the square root of 9. The square root stays there, you see, so it's the square root of 9.
oh,
And the square root of 9 is 3. So that's why it disappears, because the square root of 9 is 3. So to you, it looks like, okay, the square root is just disappearing. For instance, if I had square root 3 times square root 2, so now the things inside the square root are different. This
oh
would
yeah, it's not the same.
Yeah. So because it's different, it's just going to be equal to square root 6 or whatever that multiplication is. Thank you, Cole. I'm going to ask someone else. So, Muhammad.
So I square rooted both sides to get rid of the big square root.
You square rooted
Sorry,
both sides.
not
Okay,
square
wait.
root.
So are you saying that you put this entire thing? Let me just put brackets around it. So did you put this thing under a whole big square root like that?
No,
No.
not meant. I put the whole big bracket around that whole big bracket. Then I set it to the power 2 and the other side to the power 2.
Okay. That's also fine. So you do it like this. Big brackets squared, big brackets squared. Okay. So on the right hand side, you'll have x squared. And what about the left hand side?
Now I'll just have 32 plus x times 32 minus x.
Okay, square root 32 plus x, square root 32 minus x. And then this is obviously difference of squares. So you just square the terms with a minus in the middle. Okay, so if you square the square root 32, that is just 32. And then you square the x, that gives you x squared. Okay, and then from this point on, it's obviously much easier to solve because you can take the x squared to the other side. You could factorize, or you could divide by a common factor, whatever. And from this point on, it becomes much easier. So let me just do the rest. Okay, so I'll take the x squared to the other side. Then I have 2x squared equal to 36. If I divide by 2 on both sides, this is equal to 8. Huh? No, 32, man. 32. Why am I saying 36? Okay, this is equal to 16. That makes sense because the square root of 16 is 4. In fact, it's plus or minus 4. Okay, and that is your solutions. Okay, so that's the very nice thing of this question. You could just, from the get-go, square both sides, which immediately gets rid of the square, the square roots on the left-hand side. And then on the right-hand side, you just have x squared, and then you just solve further from there. So yeah, hope you guys had fun with this. Definitely have a look at that last question, question 1.3, and the rest of the questions in part of this PDF. I will forward this down in the group and you guys can have a play with this.